Hello everyone, I hope everybody is fine and ready for another lecture. This technique of factoring we're going to discuss is called difference of squares. It's found in section 4.5 of your textbook. Think about it for a second. If you have two binomials in the form of a minus b times a plus b, how would we multiply these two binomials? I think in the past chapter, it was chapter 3, before March break, when we learned how to multiply binomials by binomials. And we mentioned this so-called method of FOIL, F-O-I-L. So I'm going to do that. I'm going to multiply a by a first. So that's going to be a squared. And then a times b, which would be ab. And then we multiply the inside terms after we multiply the first and then the outside terms, FO. Now we multiply the inside terms, negative b times a, that's minus ba. And then the last term, negative b times positive b, would be negative b squared, clearly, right? Now, if you look carefully at the result we got, the two middle terms are opposite terms. AB and negative AB cancel out each other if you collect like terms. Just like 5 and negative 5, they add up to 0. AB and negative AB will also add up to 0. So the middle terms will be gone actually. So what is left is actually only a squared minus b squared. So this gives us a very famous formula known as difference of squares. C, difference, that's the subtraction sign, of squares, is equal to a minus b times a plus b. A very, very famous formula in the world of mathematics. So we are going to use this formula to factor different polynomials, different expressions. For example, if you have something like 4x squared minus 9, and this is just a binomial, and you want to factor it, sometimes you may rewrite the given expressions in the form of difference of two squares. Watch this. I'm going to open up two brackets, and I put a minus sign in between. I'm going to square them. Now, I'm asking myself, what is it that when you square it, you end up with 4x squared? You may guess it is actually 2x. And what is it that when you square it, you end up with 9? Obviously, it is 3. So 2x all squared minus 3 all squared is 4x squared minus 9. And we're going to factor this. We're going to say 2x minus 3 times 2x plus 3 is actually the final answer to this question. Why? Because this is like a squared minus b squared. What plays the role of capital A is 2x, and what plays the role of capital B is 3 actually. If you just compare it with the difference of squares formula, you will figure out that A is actually 2x and B is actually 3. So the answer is just in front of us. So we just have to cheat from the formula, so to speak. So the answer is A minus B times A plus B, which would be 2x minus 3 times 2x plus 3, okay? So this is one way of factoring. It's called difference of squares technique of factoring, and this is the fourth technique that we are learning. Now, there's other techniques which I'm going to talk about. This one will be technique number 5. If you're numbering them when you're taking notes, hopefully in your notebook, in order to have an organized series of notes, you can number them and organize your notes. So technique number 5 would be something that we call it perfect squares. Now, what is this? If instead of a minus b times a plus b, if I multiply a plus b by a plus b itself, okay, so both are positive signs in between the two terms inside the brackets, and I just perform the same old FOIL method. I expand them. I'll end up with a squared plus ab plus ba plus b squared. Now, last time I did this, because I had the negative sign and I had the positive sign in between a and b, so when I multiplied them, ab and negative ba, they were opposite terms. They canceled out each other. I got 0 in the middle. That's why I end up with a squared minus b squared as the final answer. But this time, it's a different story because both of them are positive. So ab plus ab would be actually 2ab, just like one apple plus another apple would be 2 apples. So the answer here is going to be a squared plus 2ab plus b squared, right? And then the left side, when you're multiplying something by itself, actually you're squaring it. What is 5 times 5? It's 5 squared. What is 10 times 10? It's like 10 squared. So here I can write a plus b all squared. And this formula I just derived is called a perfect square identity or perfect square formula in mathematics. Now, you may ask what happens if we have a minus sign in between a and b. Well, I think the same thing I explained applies, but the difference is that instead of plus plus in the middle, instead of positive 2ab, we will end up with negative 2ab. You may want to try this at home by yourself and derive it. So we end up with these two formulas known as perfect squares. I give you an example. I picked this from the textbook. It's one of your homework questions. It says 49a squared plus 56a plus 16. And the question says factor. So we have to factor this quadratic trinomial. Now, before rushing and before starting to use the former technique I taught you, it was number 3, decomposition method. Before you do that, you just hesitate for a moment and carefully look at the first and last terms. You may notice that 49 is a perfect square. So the first term can be written as 7a all squared, actually, believe it or not. And then 16 can also be written as 4 squared, because that's a perfect square too. Okay, maybe we got lucky, I don't know. The middle term, let's see how we can write it. So 7a all squared plays the role of capital A squared, and 4 plays the role of capital B. Okay, so far everything matches with our model. We called it perfect squares, except the middle term. We have to check to see if the middle term happens to be a 2ab or not. So let's try. We have 2 here, and what plays the role of capital A is 7a, and what plays the role of capital B is 4, as we said. And what is 2 times 7 times 4? It's going to be 56. Bingo. So the middle term is actually perfectly matching with 2ab. The first term is a squared. The last term is b squared. So what you have in front of you, in fact, is a perfect square. And if it is a perfect square, you can write the answer in the form of a plus b all squared. So I'm going to write 7a plus 4 all squared. There we go. So it was sort of easy. So that's another method of factoring. Perfect squares, we called it. Technique number 5. I want to do one more, okay, before I run out of time. I hope you're going to watch these videos multiple number of times. You know, you're going to pause, you're going to hesitate, you're going to rewind, you're going to watch it again, you're going to redo it. You got to spend the hours at home, you know. But I have no choice. In only a few minutes, I got to deliver the curriculum to the best of my abilities. So I'm going to move on to technique number 6. It's a very easy and short one, and I'm going to quickly mention that. And this number 6, okay, it's called grouping method. So grouping method is another method of factoring. Now, what is this all about? I picked the question from the textbook, page 204. In order to kill 2 birds with one stone, number 10C. Okay, it says 3mx plus 3my plus 2x plus 2y. It says factor the following expression. Now, sometimes we can factor by grouping the terms. For example, if I take the first 2 terms together, if I group the first 2 together, and I group the last 2 together, I will have some common factors often times. So I end up with 3m, I factor it out, that's the GCF, x plus y, and then here 2 is the common factor, that's x plus y, and you see that in the next step, clearly x plus y, that binomial, is the common factor. So I'm going to factor x plus y in the last line, and the answer would be x plus y times 3m plus 2. Okay, using the first technique of common factoring we learned in the very first lecture. So oftentimes you can factor polynomials by this so-called method of grouping. And what you're doing, you're grouping the terms. You're taking the first 2 terms together, or the last 2 terms together, or sometimes the first term with the third term, and so on and so forth. Let me give you another example. 5my plus tm plus 5ny. Again, I selected this from the textbook. I think this is number 10D. So that was 10C. This is 10D from the textbook, page 204. Now, how would you do this one? At this time, I'm going to, let me erase this part of the board. This time, I'm going to group the first term with the third term and the second with the fourth term. So basically, I'm going to write 5my plus 5ny together. Okay, I group them. And then plus the second and the third terms, I'm going to group them separately at the corner. Okay, I have not changed the problem. It's the same question. All right, same question. I didn't change it, except that I just grouped them. Now, if you can't see this properly, it's 5my plus 5ny. I read it for you, and it's tm plus tn. So now I say 5y is the common factor between the first two terms. I factor it out. I get m plus n. And between the last two terms, t is the common factor. So you factor it out, and you end up with t times m plus n. And clearly, m plus n is the common factor for the last step, just like previous exercise. So the final answer would be m plus n times 5y plus t. Okay, this method, which was number 6, is called grouping method, and it's used sometimes to factor polynomials of the form you saw in question 10C, page 204, or question 10D. And there's other exercises in the textbook. I bet you will be doing those questions. Okay, so I think I'll be left with shortcut methods for this whole unit on factoring, which probably I'll explain it in the next lecture. Thank you.